All right, welcome to Objective 6. This is the walkthrough for the Splunk challenge in the Holiday Hack event. And this one obviously involves using Splunk. Splunk is a widely used, basically de facto tool for aggregating logs and being able to search and analyze them and index them. So it's widely used in. I mean, I guess you could put any data you'd want into it, but it's very prevalent in security operations. So creating dashboards and alerts to alert on specific events that are going on in your environment. It can help discover attacks as they happen. Either as they're in progress, or you can use it for threat hunting, or breach response, after the fact. But it's a awesome tool that allows you to very granularly and with a lot of flexibility search and find information that I guess you're looking for from a lot of different log types and files from different systems. So it's a great tool to learn, especially if you're in cybersecurity. And I will say I know less about it than I'd like. So having these challenges and forcing you to use the tool is always a great excuse to learn a tool that some of us might not use on a daily basis. But anyway, let's hop right into the challenge. So so it says access the Splunk terminal. What is the name of the adversary group that Santa feared would attack KringoCon? So that is actually the final question of this assessment or this challenge. But anyway, if you click on the Splunk, I guess system here, you get launched into another tab. Here that has a custom dashboard with like a chat application where you get some hints, and then on the right side of this dashboard, you basically answer questions. And so you start with these training questions, and then at the end you finally get to the culminates in the challenge question, which once you basically get all these done, you get awarded the points or whatever for this objective. So first things first, we'll go through and read this. So it just talks about it gives a link to this talk, which the link was kind of broken before. But anyway, let's see. Oh, emulating. That's so it gives a link to this. I will say near the end, this slide's going to be very important. Stay frosty. We're going to have to use that in the last challenge. But otherwise, it's a very good talk. It discusses how to essentially emulate adversarial actions. So certain attacks and stuff. Atomic Red Team is actually used in this Splunk instance, and then the Splunk attack range. And then also referencing the MITRE ATT&CK framework. So we'll get into what all that is in a second here, but it's a good talk. Definitely check that out. So we're using the Splunk attack range to simulate a number of techniques from the attack framework. So we have to go through these questions and solve them. So this elf here said that they simulated the attacks with or I believe it references it somewhere, but it's using the Atomic Red Team, which is open source, basically atomic type tests where you can execute certain adversarial actions and test your security response capabilities or detection capabilities. Okay. So then if we click this one too with Alice, it says Santa's going to participate. So we're Santa. Obviously, we need to be to do this challenge. So then they give us a hint here to get us started. So every simulation is in its own index. So the way I understand it, and I'm by no means a Splunk expert, but an index is basically a data store for a certain type of log file or data, and you can have multiple lots of different indices within a Splunk instance. Um, okay, so our first question here: how many distinct MITRE ATT&CK techniques did Alice emulate? So if we go into the search section here, we'll get into actual, classic Splunk out of the custom dashboard, and we can start search queries. So we'll use the one that they gave us to get started here, and you can see we've got all these different indices. And so the question is, how many distinct MITRE ATT&CK techniques did Alice emulate? So if you have not heard of the MITRE ATT&CK framework, it is a knowledge base of adversary tactics and techniques. So it's basically a publicly accessible information sharing, I guess, table where you can go and find different common attacker techniques, tactics, and procedures, and look at how real attackers tend to execute different parts of their attacks. So there's different stages up here at the top, or techniques, if you will. Or no, sorry, each of these individual ones, those are all the techniques. And these are different categories for the techniques. And then on top of there being techniques, there can also be sub-techniques, and that was actually recently added to the attack framework, I would say within the last year, I think. So yeah, it's a really great learning resource. A lot of like consultants or product development teams, if they have a security tool, they'll try to relate certain features or aspects of their assessment back to, they'll map it essentially to the MITRE ATT&CK matrix here. And it's just a way of categorizing certain actions, again, that an adversary would take. So so I know, like, for example, purple team assessments, the blue team will want to test against certain MITRE attack techniques and sub techniques. So anyway, so we're coming back here. The question again is just the distinct individual, the number of techniques. So sub technique is not counted as its own technique. So we just need the parent techniques and how many there are. So we've got, first caveat to say is I'm sure there's plenty of ways to write searches that are fancy and will just give you the exact number. Again, I'm not a Splunk expert, so when I went through this challenge originally, I did it pretty manually. I would use some basic searches, but then really end up looking at the results, which yes is not the best way to go about solving this challenge, but in my opinion, as long as you're able to find the data that you need, and you can manually go through it with the results you have and still solve it, then it still counts in my eyes, even though yes, it would be better to have those more refined searches. So if that's what you're looking for, I'd suggest checking out some of the write-ups that people put out for better search queries. But anyway, for the purpose of solving this question, again, we just need the number of techniques. So 1033 main and win, that just counts as one, so that's one. 1057, that's two. 1059 is three. 1071 is 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And attack is not a technique, so we're just going to ignore that one. So the total answer is 13 of the top level techniques that were emulated. Okay, and we got that one correct. And then the next one unlocked. So what are the names of the two indexes? Is indice not the... indices? Why do they call them indexes? Oh, the plural of index, directory, or catalog is indexes. Wow, I did not know that. Okay, so they're indexes, not indices. What are the name of the two indexes that contain the results of emulating the attack technique 1059, or, well, sub technique 003? Put them in alphabetical order and separate them with a space. Okay, so coming back here, 1059.003, 1059.003. So we've got 1059.003 dash main and 1059.003 dash win. And we need to do alphabetical, so we'll do main first and dash win. Incorrect. Okay, let me look at my notes here. What am I missing? Huh. Oh, I'm missing the T in it. That's my bad. All right. Number 3. One technique that Santa had us simulate deals with system information discovery. What is the full name of the registry key that is queried to determine the machine GUID? Okay, so I'm going to take this and do some searching in the MITRE ATT&CK framework. See if this pops anything. Oh, what is going on? Ah, shitty JavaScript search. Okay, here we go. System information discovery, and then we're looking for machine GUID. Maybe not. Oh, there's no sub techniques. Okay, let's do a search for machine GUID. Not popping anything. Okay. All right, let's take a look here. Okay, I forgot that. Basically, as we solve these, we get little hints from, or little tips from the chat here. So, yeah, if there's like a red glowing thing, that means there's unread stuff. So always good to look at these. Let's see. So, we got that right. Oh, looks like they actually gave us the. That's how we can get the exact number of techniques. But anyway, what's actually in those emulation indexes? So this is where they bring in the fact that they're using the atomic red GitHub repository for the simulation of attacks. And they also discuss simulating these things. Okay. Okay, so we have the technique. Now we need to figure out where in this repository do they perform this technique, and then we have to look at how they're executing that test. So let's do a search on this repository for this technique. Okay. And then let's look up machine GUID. Okay. So I think this is what it's looking for. The registry key that it is querying will be displayed from registry. Yep. What is the full name of the registry key that is queried? Okay, so we'll just paste that in there and correct. Number 4, according to events recorded by the Splunk attack range, when was the first OS/TAP related atomic test executed? Provide the alphanumeric UTC timestamp. Okay, and then this says here, the Splunk attack range keeps track of the simulations that are run in the index attack. Okay, so let's just do a search. Let's limit our index to that, and then or our scope of the search to that, and then let's do a search on just the OS tab string and see if that pops anything. So we are getting some stuff, but what are we? When was the first OS tab related test executed? Okay. So from those results, yeah, the test name. Okay, so these are all the tests that we're running. So we want to find the earliest one based on the UTC timestamp. So it looks like this one was the earliest. So we want to grab this UTC timestamp. So let's go ahead and Control C that. Bring that over here, paste it in. Okay. Number 5, one atomic red team test executed by the attack range makes use of an open source package authored by that user on GitHub. According to Sysmon, event code 1, what was the process ID associated with the first use of this component? Okay, so this one involved going to GitHub and searching for this user, FRGNCA. And then they've got a few repositories. There's a very popular one that they have on there called audio device commandlets. And this is PowerShell to control audio devices on Windows. Okay. All right. So the question is, according to Sysmon, what is the process ID associated with the first use of this component? Okay. So what we want to find out is, how does this audio, library or package or whatever, how does that map to the attack framework? So if we go over to here and let's do a search for just audio capture. Sure. Can leverage peripheral devices to capture audio recordings for the purpose of listening into sensitive conversations. Okay, so then let's take a look at our indexes and see, is that an actual one that we emulated. So this is T1123, and it looks like we do have T1123, and we know this is a Windows system because this is built for Windows, so we can go ahead and search by that index. Index equals T1123-win. And then let's do a search for audio. Okay. So I know we're looking for process. Nope. Let's enable. Is there command line? Command prompt. Let's see. Nope, that's not helping us. There we go. So now we're getting event code. Okay, so we know event code should be equal to 1. So let's restrict it to just that. Okay, then we have 2 here. Windows audio device. Okay, so what's the question asking for? What is the process ID associated with the first use of this component? All right, so if we go back to the repo, what is it actually providing? Um, audio device commandlets. Oh, here. Okay, so these are both actually using the Windows audio device PowerShell commandlet. Okay, so we need the process ID associated with the first use. Okay, well, there's only two here. UTC time. I believe this one occurred first. So 3648. So that being the process ID. All right, there we go. So this one happened just a little bit before this one did, according to the UTC timestamp. And then the process ID is here. So that's what we needed to submit for the answer. Number 6, Alice ran a simulation of an attacker abusing Windows registry keys. This technique leveraged a multi-line batch file that was also used by a few other techniques. What is the final command of this multi-line batch file used as part of the simulation? Windows registry run keys. Okay, well, let's go to the framework and look at registry run keys. Ah, perfect. Okay, boot or logon auto start execution, subtechnique, registry run keys. Okay. So now we know the technique, so we can, this is this one, this technique. So let's go back here. Take a look at our list of indexes. Okay, well, we know it's got to be Windows, so let's pick the Windows index. Or not. -win. All right, and then let's do a search in command line for anything related to bat, which is your batch files. All right, looks like we get some responses here. Leverage a multi-line batch file that was used by a few other techniques. Okay. Yes, so when I was originally solving this, one of the things that I did, I actually went into this here and looked at the T1547, T1. Five, 4, 7. Yeah, and I was taking a look at what. Oh, that's not it. Yeah, so I believe it's using. Says it gave us a hint that this is being used in a few different techniques. This one looks like it is, being reused. So discovery.bat, this is in miscellaneous. The way this is structured looks like it could be reused. So the last command here is queuser. So then let's try and match that, see if that seems to align. So we'll do a search for a queuser. That doesn't seem to be popping up. So let's see if it pops up as Do a search on discovery.bat maybe. Maybe that'll pop. .bat. Nope, it's not. Okay. Oh, here we go. Discovery.bat. Let's take a look at this here. Okay, well, I don't know if we can find, we probably can find the full contents of it, but we can see it here that it's quite literally downloading this batch file, and we know from looking at this that the last command is queuser, so we'll go ahead and paste that in there and see if we're right. And we are. All right. And finally, according to X509 certificate events captured by Bro, what is the serial number of the TLS certificate assigned to the Windows domain controller in the attack range? Okay, so this one is getting quite detailed on what it wants us to find. So we are looking for the serial number of the TLS certificate assigned to a Windows domain controller. Okay, so we know that the I guess source is from Bro. So we can use the Splunk. So we'll just search on all indexes, which is the asterisk, and we know that the source type is Bro. Not sure entirely on the name of it, so I'll do asterisk before and after. Okay. Okay, so then the host, these are all the logs from the Zeek or Bro host. Now let's also do a search for DC, see if domain controller pops anywhere. Okay, SSL JSON, X509 JSON. Okay, so let's try this. Let's do Bro colon SSL colon X509. Let's restrict it to just that source type and see if that pops anything. Oh, do I need parentheses? Okay, not sure what's going on there. Add to search. How do I? Oh, there we go. Oops. There we go. All right. Source type, Bro X509 JSON. All right, so now let's just DC pop anything. It does. What do we have here? Okay. So win-DC, usually that's a naming scheme for like a domain controller. And what specifically are we looking for? The serial number of the TLS certificate assigned to the Windows domain controller. Serial number of the TLS certificate. Okay, serial. Certificate.serial. Issuer. So I believe that this is our serial number. So we can copy that and attempt to submit that. And that's right. Okay. So now finally here. The last one is encrypted using your favorite phrase. The base64 encoded ciphertext is the following. It's encrypted with an old algorithm that uses a key. We don't care about RFC 7465 up here. Okay, so first things first, we need to decode this base64. However, because we are decrypting something, my guess is it's not going to be readable ASCII or whatever. Um, and then it mentions RFC 7465. So let's take a look at what that is. So this is actually a RFC document that talks about prohibiting the use of RC4 ciphers, which is a weak cipher suite. And I believe you can. There's some stuff with Kerberos and Kerberosing that you can do with RC4 cipher suites, but the TLDR of it is that it's here does not provide a sufficiently high level of security. So basically, it can be broken quite easily. And this is a document that these people have written up as a proposed standard to prohibit the use of RC4. So this is a big hint to tell us that this is likely ciphertext resulting from RC4, and we need to figure out a passcode that's going to allow us to get the plain text out of this to submit as the final answer. So we can use, I believe it's CyberChef, if I'm right. CyberChef is an online tool that it's very useful for like CTFs and stuff, but allows you to basically just play with data, do all sorts of different things with hex dump, base64 encode decode, encryption, decryption. So we've got RC4 here, which is perfect. So we've got, let's see here, data format. All right, so we've got our base64. We basically want to decode that into whatever, hex output, whatever it's going to be. Decode that base64 string into ciphertext that we feed into RC4, which then we will also pass a passcode with it, and then that will give us the resulting plain text, which will be the answer for the final challenge. And I will say, as mentioned before at the beginning of this talk, that you should have watched the talk for this challenge, which if I can find that link again, forget it. YouTube. This one here. At the very end, the speaker shows this slide, stay frosty. So that is the password that we're going to feed in here. And that's where we need to solve this challenge. All right, so you'll notice that I've pasted the encrypted and base64 encoded, ciphertext into the input box here in CyberChef. I have base64 and then in the recipe followed by RC4, which is going to decrypt this with the stay frosty passcode. And the output that we get is the lollipop guilt, which is the final answer for the challenge question. Correct. Okay. Congratulations. So then if we come back here, I think we should, oh no, I think it actually asks us to paste the answer in there. Yep. So we just paste that in there and we get the points for it. Cool. Well, let me know if you have any questions. I know I'm not a Splunk expert by any means whatsoever. Again, check out some write-ups. You can find links in the Discord, and I'm sure other people have some really great write-ups on with perfect queries that get you the exact answer. So my approach is more I guess brute forcing. I'll try to narrow down my pool of log data a little bit and then just manually sift through, which admittedly is not the best way to do things, but for this challenge it worked. And slowly I am picking up more and more of this Splunk query capabilities and stuff like that. So great challenge all around. I'm glad they try to integrate some of these commercial tools that are so widely used in industry, because it's it's a great learning experience. So, but yeah, let me know if you have any questions. If not, we'll see you in the next one.